So again, we're starting on these rotations notes, which are in the class notebook under chapter 4, the notes. These other ones with the C4, L1, 2, 3, 4, those are blanks. They are in the Cornell note format. And that's if you want to do these notes while you're watching the other video, which will come later, then you're welcome to do that. But right now, what I'm going to do is put these under the camera and we'll fill them out together. So however you want to do this, like I said, if you need an extra minute to get them off the printer, go right ahead. I'm just going to put them under the camera and hopefully get it to focus. Every day it fights with me on the focusing. There we go. I can lock it. I know it's a little shiny, I'm sorry, but I'm trying to save, paper and ink. So if I put it in this sleeve, I can only use 1 copy instead of 3 copies. Okay. So a rotation is a transformation in which a figure is turned, so remember turned, about a fixed point called, gotta move over here. Appropriately enough, it's the center of rotation. Well, you know what I didn't do? I didn't tell you what our objective is. So our lesson objective, in other words, what I'm hoping that you will get out of the end of this is that I will be able to perform rotations, perform composition, with rotations, and identify rotational symmetry. Of course, I'm going to go ahead and put my name on the name title. Okay, so this is where hopefully I'm going to grab some colors and be able to point some things out. So a rotation about a point P, okay, let's say P is here, through an angle of X degrees. So this could be any degrees, maps every point Q in the plane to a point Q prime, right? So we're going Q to Q prime, so that one of the following is true. Either if Q is not the center, then QP equals Q prime P. And the measure of QP Q prime equals X degrees. So, and if Q is the center, then it's the same. Then Q equals Q prime. So if Q is not the center, which is if we're going around P and Q is not the center, then QP is equal to Q prime P. Those two lengths are equal. And here's the other part, that this angle between them, that's your X degrees. So if you move it 90 degrees, then that angle should measure 90. If you move it 200 degrees, that should be 200. And that's all you need to do is understand right now the definition. So for instance, and I'll again do this in color. if I were going to measure over here, okay, P is my center, and this is my original figure. So what this means is PA is going to be the same distance as PA prime. And, you know, while I'm at it, you could do this with any of them. So like PB is the same length as PB prime. So I hope you can see the color there that's showing. And of course, PC would be the same as PC prime. And then the X here would be the angle between those lines. And the X is the same for each. So for instance, the measure of angle A, PA prime, would be 60 degrees. And also if I did between the green, the purple, that would be B prime, would also be 60 degrees. And then between C prime would be 60 degrees. So there's only 1 degree, and they all have to move or rotate that degrees. So hopefully that will get you started on that. Now, if I'm going to rotate counterclockwise and clockwise, we need to define that just a little bit. So for any point P, okay, I'm just saying P is my center point, then we're always going to define counterclockwise this way, which is our default, meaning if it doesn't say anything, we assume that it's counterclockwise. However, say you have P here and you want to define it the other way, you can do this, but this is not, it's not the regular way, but you can. You have to write the word clockwise though. Okay, so I'm looking and I'm asking, are there any questions yet? This should all be basically review, but the definition looks different probably than when you saw it in 8th grade. Okay, so when I say the word about, that means around. So when I say that something has been rotated about a point, it actually means the word around. So that means it's being rotated around that point. Okay. Oh, no questions yet. All right. Now, super duper important. These are very difficult to visualize because, unless it's like a perfect square or something, which most people can't do. So what we're going to do instead is we're going to learn these rules about how the numbers change. And then once you learn the rules about how the numbers change, you can graph the other one without hesitation. So here's what happens. And these are just the rules. This is the way it works. I have rotation rules for 90 degrees, 180, and 270. Why are there no rotation rules for 360? Anybody know? What if you rotate something 360? Doesn't it look exactly the same? Caesar, is that what you were going to say?
Yeah, it becomes a whole circle.
Okay, thank you for volunteering. I didn't see the hand in time. Yeah, so it goes all the way around. So really, you only need to know 3 rules. Here's your 3 rules. Whatever your point is, X, Y, if you go 90 degrees, the points switch, and then the one in the X turns negative or becomes the opposite sign. If you go 180 degrees, they both just become opposite signs. So like it would be going from first quadrant to third quadrant. And then if you go to 70, you go from first to third. So let me just show you a quick example over here. So say I have, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 7, 9. It's just some point. Here's my origin. Oh, it's right exactly on the shiny part. Okay, so if I want to do a rotation of 90 degrees, okay, this is just so you can see it. Rotation of 90 degrees, the rule says xy will map to negative yx. So then here's my x, here's my y. Then this is going to become, the 9 goes in here with a negative, and the x goes here. So if I do this one a 90-degree rotation, then I'm going to graph this one to negative 9, 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. Now I'm here. If I want to take this point and I want to do a rotation of 180, you can see where this is going. The rule on our sheet says that xy turns into negative x, negative y. So x is 7, y is 9. This will become negative 7, negative 9. So negative 7, negative 1, 2, 3, 4, 5, 6, 7, 8. Whoops, I wrote right on the top of it. So there's the point if I want to do 180 degrees. And then obviously if I want to do right here so I don't, and if you want to do a rotation of 270, then it's going to be, let's see, our rule is that it turns into, checking my notes here, y negative x. So 7, 9 would turn into 9, negative 7. So 7, 9, 1, 2, 3, 4, 5, 6, 7. And so how you would measure this, like to know, if we were in the classroom, I'd be giving you paper and rulers and graph stuff, and you'd be doing this. But basically, here's how it works. Since these are rotating around here, this is how you check your angle. Doesn't that look like a 90-degree angle? And then from here to here, that's a 180-degree angle. And then from here to here. So see, these are all 90-degree angles. If you just sort of turn it a little, now you should be able to see it. So the hard part, of course, is if you're not doing 90-degree angles, but we're going to mostly just stick to the 90, 180, and 270. You can do other angles, but it's harder, and I don't know if you have protractors, and we'll see how that works. But the point is, if you just start with your figure and follow the rule for each rotation, then you'll be good. And here's another way to remember. On the 90 and the 270, they swap. Okay, the y and the x swaps. On the 180, it should be easy to remember. All it does is turn negative. So those are the same. So these swap. And then to remember the signs, all you have to do is think about what quadrant you're in. Like this is quadrant 1, so everything is positive. All your points. This is quadrant 2, so your x is negative, but your y is positive. See, your x is negative and your y is positive. Down in quadrant 3, both things are negative. And then in quadrant 4, your x is positive and your y is negative. So if you remember your quadrants, it'll make these rules even easier to remember. Okay, so hopefully that helps a little bit. I'm going to go back to the actual notes we were writing, but I wanted to explain a little bit, where these rules came from, and that this is the most important part right here. That's why I did orange and highlight and all that. So just to reiterate, unless otherwise stated, a rotation will always be counterclockwise. And you may see it sometimes written as CCW, which would be like, what the heck is that? Okay. So what we're going to do is we're going to graph a quadrilateral. And we start with Rstu, and then we're going to move it to 270. Okay. So our rule for 270 is right here. So I guess let's start with Rstu. So R is 3-1. S is 5-1. T is 5-3. And U is 2-1. I'm going to carefully draw them. Use a straight edge if you're not very steady. Okay, so I have Rstu. And it says about the origin, so this is my pivot point. And like I said, if we were in class, I would have you hold your pencil here and trace it on a piece of paper and then actually move the paper 270 degrees around. But because that does help some people. So if you'd like to try to figure it out that way, you can too. But here's how I do it. So we start with R, which is 3-1. And we're going to change this so that R prime is my 1 goes here, because that's my Y, and then my X turns negative. That's going to be R prime. I'm going to do S, 5-1. So S prime will be 1, -5 to follow that rule. T is 5-3. So T prime is, I'm going to take the Y, put it here, but make it, that's a negative. And then I'm also going to make my X negative because now I'm in the 3rd quadrant. And U is 2-1. And U prime is going to be -1, that's my Y, and then -2 is the opposite X. So see, I have to be really careful if I'm talking at the same time so that I can get these exactly right. So I'm going to try to do it with, let's see, blue. Let's try blue. Well, green will show up. Let's see. Okay, and so now I can graph these, and hopefully it will look like a 270-degree rotation. So R prime is 1, -3. S prime is 1, -5. That's why I was telling you, get your colors out. This will be helpful. Okay, -3, -5 is here. That's going to be T prime, and U prime is -1, -2. And then I can connect to my dots. R, S, T, U. And if you did measure the degrees between any two vertices, I'll just do U because it's the closest to the origin. You could do this on any one of these points, and if you measured it, you'd get 270 degrees right there. That's how you do that. Of course, you could measure the other one here and get 90, and you'd be just the same. All right, so any questions yet? Is this looking a little bit familiar from 8th grade at all? Anyone? No? Okay. So it is a full day of notes. I'm going to turn the page. Try to get those. Is that better? It's a little better, huh? Not much, though. I'm just going to leave it on. Sorry. Okay. Remember, a full rotation is, we already discussed this, 360 degrees. And so that's how you just do a basic rotation. Now, the second part, there were 3 goals. The second goal, what I'd like you to be able to do is recognize rotational symmetry. And this is largely a gift for some people. And it's on all kinds of tests where they give you like, this figure looks this way in the first 3 translations, and then you sort of have to guess at what the last rotation would look like. I am not gifted this way, but it's funny, my twin sister is. She can tell you what it looks like, and I'm not exactly sure how. I need to see the numbers. She can visualize it in her head. So depending on which one you are, you'll see, we'll see which one you are too. Especially if you're a creative or an artist, or you want to go into the ad business. A lot of logos have rotational symmetry. Okay, anyway, I'm blathering. A figure in the plane has rotational symmetry when the figure is onto itself, this is the most important part, by a rotation of between 0. Now, in the book, it says between 0 and 180, but I'm going to say 360 about the center, because you could technically have symmetry around like 200 or 270 or something like that. If you made it like that, that's much less common than 180. So this is either 360 or 180, but you'll see. The point in which the figure rotates is called the center of symmetry. So that's a word that we'll use all the time. Note, it can be either clockwise or counterclockwise. There's no like default on rotational symmetry, but it's said to have point symmetry when the figure has an angle rotation of 180. So this specifically will match point for point if it has 180. Now, when it says use your trace paper to help you determine that, what we would do is we'd take trace papers, these little pieces of wax paper, and we would draw our figure, and then we would try to spin it and see if we could match it. So you're going to have to do this like imagination-wise, because I don't have graph paper. I don't have those little pieces of wax paper. You're just going to have to sort of guess. But this is the center of my star, right? If you did, let's say you had a piece of construction paper and you cut out that star, could you rotate that piece of construction paper to match the figure exactly?
Yeah.
Thank you. Somebody answered. Yes, thank you. And of course, you should all be nodding your heads. Yes, of course you can. And all you'd have to, it says determine whether it has rotational symmetry, and you say yes, since the star maps, and I'm just gonna, write the whole maps onto, it's maps onto itself. Maps onto itself with a rotation of less than 360. Now, you may or may not know how to do this part, but again, that's why we're doing the notes and I'm showing you how to do these examples. What is the smallest angle that maps the figure onto itself? So if you had a piece of paper and you were measuring it from here to here, it'll look the same again. It'll also look the same if you do it here and here and here. And so to determine this, really, it can be mapped onto itself once, twice, 3, 4, and then technically 5 times. Okay, so 5 different times you can do this. What you do is you divide a full rotation, which is 360 degrees, by the number of times it can get mapped onto itself. Which means for us, we're going to do 360 divided by 5, and that gives us 72 degrees. Of course, this would normally be group work, but since it's notes, the first rotation here is 72. The second rotation is going to be another 72. And Jimmy, 3 minutes. The third one's going to be 260 degrees, and the last one will be 288 because we don't count 360. But that's 5 different times that you can rotate it. So here we go. If we just, and, oh, I skipped one of the, okay, this is the answer to 3, and this is the answer to 4. Sorry about that. Number 3 is 72 degrees. This is number 3. And then describe what your group did to find it is, whoops. Okay, so this goes here. This goes here. And this is number 3, sorry. Well, it's not always perfect. Questions? Okay, so I'm gonna try to finish up here with the last one, a composition with rotation. The only thing a composition means is that you're doing more than one transformation. So you could do a rotation with a translation. You could do a rotation with a symmetry, flip, like a reflection. You could do a translation and a reflection and a rotation. And that's all that composition means. So what you're going to do is you do them in order. So if it says reflection first, you have to do that first. And you just write out your rules, and then you will know what your points are, okay, with the image. So we're just going to start with a simple segment, RS. So RS has segments 1, -3. And S is 2, -6. So there we go. What we're going to do next is reflect it in the y-axis. So the reflection in the y-axis, we're going to start with 1, -3. We'll do R prime. And R prime all it does, here's the y-axis, so you're going to flip it over this way, which means your y's will stay the same, but your x's will go from positive to negative. So this is going to turn into -1, -3. I'll do the same for the s. So s is 2, -6. And if I reflect it here to here, right, my 2 will become -2. And my -6 stays the same. So that's the reflection. Now, if you want to, you can also draw that in. That would give you -1, -3, and -2, -6. Okay, that's your first reflection. And then it says rotate 90 degrees about the origin. So if you remember the rule from the other side, and this is going to now be r double prime, this double prime. We're going to take this x and this y. We're going to flip them so that now this is in the first place and this is in the second place, and then we're going to make the x positive, or we're going to change the sign of the x. So r double prime is now 3, -1, and s double prime is going to be 6, -2. And that's how you apply the rule. So now we can graph these numbers, 3, -1, and 6, -2. Of course, this is r double prime, s double prime. Which, if it were me in my notes, here's what I would be doing. I'd be making this green, I'd be making this green, and I'd be making this green. And I would probably make this, some other color, or if I had a highlighter, I would make this purple, and I'd make this purple, and I'd make this purple. So that would really visually clue me in that this is here, the first transformation, and this is here, the second transformation. Because I would need that. I am not gifted this way. Okay, so we have one more example. And here it is. Graph AB with endpoints -4, 4, and B -1, 7, and its image. So I know it's only going to be up in here because the graph says that. So -4, +4 is right here. That'll be A. -1, +7. 1, 2, 3, 4, 5. Make sure I know which one that is. That'll be B. So here's AB. Now, first we're going to translate it, right? We're going to move it, and then we're going to rotate it. So the other way you could do this, if you want to do 90 degrees clockwise, is, like this way. You can consider, since our 3 rules only cover 90, 180, and 270 counterclockwise, this is the same as 270 degrees counterclockwise. So I'm going to use that rule. I don't have to learn a whole nother one. I just have to understand that that's where that is. So I'm going to start with A. I'm going to go to A prime. Start with B. Go to B prime. So if I'm just going to translate it, my x goes down by 2, my y goes down by 1. So -4 minus 2 is -6. 4 minus 1 is 3. -1 minus 2 will be -3. And 7 minus 1 will be 6. So that'll be my translation. So A prime is 6, 3, and B prime will be negative 3, 6. So it does, it looks just a little shifted. Right? Then I'm going to apply my 270 counterclockwise rule to get A double prime and B double prime. So the 270 clockwise rule is you flip the X and the Y, only in the fourth quadrant, remember, it's your Y that's negative. So this rule switches these, and then this one turns opposite sign. So this will be 3, because that goes here, and then 6 turns positive because it's the opposite sign. And then this 6 will go here, but then this opposite sign will go here. So now I'm at 3, 6 for A double prime, and I'm at 6, 3 for B double prime, and I'm just going to go straight for my purple instead of make it black, because these now match. And again, if you did want to check the angle, it would be the angle between A and A, like from here to here would be a 90 degrees counterclockwise. 90 degrees clockwise, sorry, 90 clockwise from left to right, 90 degrees clockwise. Okay. And again, it would be the angle between these two would be 90. So I know it's a lot of notes for you to digest right now, and it is sort of all brand new and stuff. I'm gonna, that's all I'm going to require of you today, and it's 9:07, so we can end our meeting. If you have a question, hang back. Otherwise, let me stop this recording, and it will show up in the stream of our class anyway.